This is how AI reasoning actually works, or at least how we talk about AI reasoning without immediately lying to ourselves for comfort. A dangerous project. Because reasoning is one of those words that starts clean and then gets dragged into marketing until everyone is standing around covered in adjectives. In humans, reasoning usually means working through a problem, using facts, rules, logic, experience, consequences. A little doubt, if the room is lucky. In AI, reasoning usually means the model can produce useful intermediate steps, connect ideas, follow constraints, and arrive at an answer that appears to come from structured thinking. Appears, important word. A language model does not reason by sitting quietly inside itself and contemplating truth like a tiny monk made of matrix multiplication. It generates tokens, but those tokens can form reasoning-shaped paths. Steps, plans, comparisons, arguments, calculations, checks, corrections. That happens because training data contains a lot of examples of humans reasoning in language, math solutions, essays, debates, code explanations, scientific papers, troubleshooting guides, legal arguments, forum posts where someone is technically correct and emotionally unbearable. The model learns the patterns of those structures, not just the words, the shape. If a problem looks like this, a solution often unfolds like that. If a question asks for comparison, list criteria. If a task has constraints, track them. If a conclusion needs support, build a chain. During inference, the model can generate that chain one token at a time, and sometimes that chain helps a lot. Breaking a problem into steps can improve the answer because each step creates new context for the next step. The model writes part of the solution, then conditions on what it just wrote. It leaves itself a trail, a breadcrumb path through the problem, which is useful provided the breadcrumbs do not lead straight into a swamp. This is one reason reasoning models often spend more tokens before answering. They are not just blurting out the first clean-looking response. They generate intermediate work. They search through possibilities. They may evaluate options, revise a plan, or check whether an answer fits the constraints. Under the hood, this can involve different techniques, more inference time compute, more steps before the final answer, sampling multiple possible paths, using tools, calling code, checking results, verifying against retrieved information. Sometimes the reasoning is mostly the model producing better intermediate text. Sometimes it is a larger system wrapped around the model, forcing it to plan, act, observe, and revise. That distinction matters. Because reasoning is not one magic organ inside the machine. It is a behavior produced by architecture, training, prompting, tools, search, verification, and enough compute to make the answer sweat before it speaks. Now, does that mean the AI is reasoning? Depends what you mean. Which is the traditional way humans ruin useful questions. If you mean, can it produce structured problem-solving behavior? Yes, often. If you mean, can it manipulate symbols, track constraints, compare possibilities, and use intermediate steps to reach better outputs? Yes, in many cases. If you mean, does it understand reality the way a human does, with grounded experience, responsibility, and a body that can suffer the consequences? No, not that. That remains disturbingly unavailable. The practical point is this. AI reasoning can be real in its effects without being human in its nature. A calculator does real arithmetic without understanding your mortgage panic. A chess engine makes strong moves without loving the game. A language model can solve problems without possessing the full inner life you are tempted to project onto it. The danger is overtrust, because reasoning-shaped output can be wrong. A model can make a bad assumption in step one, then build a beautiful staircase to the wrong floor. It can explain an error so elegantly that the error starts to look employed. That is why reasoning systems need checks, tools, grounding, verification, tests, external facts. Human judgment, tragic as that may be. So, how does AI reasoning actually work? A model uses learned patterns of structured problem-solving plus inference time steps, context, tools, and sometimes verification to generate outputs that can work through problems more effectively than a direct answer. It is not magic. It is not necessarily human-style thought. It is language, structure, search, and computation arranged well enough to produce something that can be useful, fragile, impressive, and occasionally full of itself. Which, to be fair, is also how most committees operate.